ready to start examining the atom and elements. We spent chapter 1 really focusing on measurements, both the numbers associated with measurements and the units associated with measurements. We learned how to work with those and manipulate them. And we will come back to numbers and we'll start doing calculations again. But for now, we're going to back off of the number world, the measurement world, and we're going to actually start looking at chemistry. And the chemistry is founded upon our atoms. So let us start with this slide, which is section 2.3. Now what happened to 2.1 and 2.2? Well, the sections 1, 2.1, 3.1, 4.1 is always a interest point, something to grab your interest, and I would recommend reading those. You're not going to be tested on them, and so it's up to you. In section 2.2, we're really just not going to cover anything with that, so we're going to jump right into the world of the atom. Now, before we talk about the atom, however, there is this law. It's the law of conservation of mass. And what they started examining before they came up with the concept of atoms, they started examining chemical reactions. So the people who were dealing with the chemistry of the day were taking things and adding them together and reacting them and forming new substances, and they were making measurements. And what they found is, in every case, however much you started with in your reaction, you would finish with that much. So the law is stated this way: in a chemical reaction, and we know that that's the same thing as chemical change, matter is not going to be created nor destroyed. However much matter was there, and we measure that by mass, how much matter was there at the beginning is still going to be there at the end. So as we examine the reaction that we see there on the screen, we see that we start with some sodium metal, and they weighed out 7.7 grams of that sodium metal. And they dropped a little piece of that sodium metal into a flask that contained some chlorine gas. And there's 11.9 grams of chlorine gas there. Now, when those two things combine, it's a very bright flame kind of pops up there. And then you have a coating of this sodium chloride, which we know that's table salt, coating that flask. And if you go and you weigh how much matter was there at the end, it would have to be the same amount, 19.6 grams of sodium chloride. So in every case, in every chemical reaction, that this is true, and that is a law for us, law of conservation of mass. So then the scientists start saying, okay, this is what we observe, this is what we know, and so often after an observation and a law, they start scratching their head and say, why? Why is this true? What is happening? And they start developing theories as to why this would always be the case. And this led to Dalton's atomic theory. Sometimes we just call it atomic theory. So this was John Dalton, and he was coming up with what's happening that might explain the observation that we see here. And when he came up with his statements, Dalton's atomic theory statements, this really marked the beginning of modern chemistry and gave us so much of what we hold on to as true today. There are basically 4 statements of Dalton's atomic theory. Now, not all of those statements were completely accurate. Some of them had to be modified along the way. We're going to see why and how they're a little off, but these were the statements that he made, and some of them are dead on and accurate to this day. Okay, so here's the first one. If you were to look at an element on the periodic table, for example, aluminum, okay, take that aluminum, and what he stated is if you take an element, that element can be broken down into tiny indestructible particles that he called atoms. So this was the beginning of this idea of these little pieces of atom. So that was his first statement, that elements are composed of these indestructible particles called atoms. His second statement was that all atoms of a given element are going to be identical to each other. So if you have that piece of aluminum and you could break it apart into all of its little atoms, each one of those atoms would be identical to each other. And then he also took it one step further and said, well, all of those atoms are going to be different from any other element. So let's take a piece of iron and let's pull the little atoms apart from it and look at those atoms. Those atoms would be different than aluminum atoms in every case. So this is this idea that these atoms are the building blocks of this element. So we use the word element to describe a group of atoms in which all the atoms are identical to each other, and that makes up the element. Third statement. okay? If you had a compound, compounds are composed of atoms of more than one element. So you take some of this element and some of this element and combine them together in a certain way, and that makes a compound. That's his third statement. And the fourth statement says that when you do a chemical reaction, you are only going to separate atoms from each other and reform them together in new ways to make new substances. That those atoms in the course of the reaction are not created nor destroyed. So whatever atoms were there to begin with are still there at the end. And that is really the foundation as to why the law of conservation of mass would be true. Because if all you're doing is rearranging the pieces to form something new, of course the quantity of matter that's there is not changing. And so you are not creating matter, you're not destroying matter, you're just rearranging those atoms to make new atoms. Okay, so those are the four statements that you need to commit to memory. You need to see how this explains what we understand about the law of conservation of mass, why this helps us explain that. Now, here is just a visual image of what I just described with some of those statements. Okay, so statement 1 says that an element is composed of these tiny atoms. So we see element A in blue, we see element B in green. We see that all of element A, all the atoms are identical to each other. And we see that all of the element B, all the atoms are identical to each other. And so that is part of his statement. And the third one is that compounds are simply a union of elements. So we see a compound with the green and the blue coming together to make a compound. Now this image here does not show a chemical reaction taking place in which atoms are separated and new compounds are formed, but this gives us a visual image of those. Okay, now I want to go back to the statements, so let's go back to them and let's kind of examine them for just a little bit. Statement number 1, elements are composed of tiny indestructible particles called atoms. We are going to see that this was a good starting point, but this is not true. They have been able to take an atom and split it. They have been able to take an atom and turn it on the level of the atom into new elements, and that is a world of nuclear chemistry. So while there's something about all of them that is hard to destroy, they're not indestructible. The second one says that all atoms of a given element are identical. We're going to see that that's not quite true either. This was Dalton's first attempt at understanding the atom, and we're going to see that there's something about each one that's identical, but there's some things that can vary as we look at them. So those have some variations. But number 3 holds true completely to this day. Number 4 holds completely true whenever you're dealing with a chemical reaction to this day. So we've got those 4 statements of Dalton's atomic theory. Okay, and there is where we'll see some of the what is the word I'm looking for? A massaging of those statements to see what's really still held as true. We're going to learn about something called isotopes that helps us understand that not atoms are exactly identical, but it really won't be until chapter 19, and that's Chemistry 107, before we really start understanding that these atoms are not indestructible. So that kind of gives us our feet wet with regard to Dalton's atomic theory, understanding what atoms are.